In this video, we're talking about binomial expansions. To understand binomial expansion, we need to understand the word Pascal triangle, how Pascal triangle is formed. We need to understand it before we proceed in solving for binomial expansion. So starting from Pascal triangle, it starts with 1. So this one's come down. Then we assume there's this 1 here. So we add it 1 plus 1. We assume there's an invisible 1 here. So say 1 plus 1 gives us what? 2. And this one also comes down again. So after that assumption, then we proceed. It's just starting from here. After this one, this is the first. This one's come down. Then we assume there's an invisible 1 here. Then you put 2, which is 1 plus 1 gives us 2. And this one comes down back. That's all. Or in some cases, this one comes down. Then we have 1 plus 1 gives us 2. And this one comes down. And that's all. But in most cases, people assume that there's an invisible 1 here. We put this one down. 1 plus 1 gives us 2. This one comes down, and that's how then we proceed. Then the assumption ends there. Then proceeding, we have this one also comes down. We have 1 plus 2 gives us 3. 2 plus 1 gives us 3, and this one comes down. So that's okay. We proceed. We say 1. This one comes down as well. 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4, and this one comes down. So if we go back, we notice something. There's something reoccurring. When this one comes down, this add this gives us this add this gives us this, and this one comes down. We proceed. If you notice again, this one comes down here. This add this gives us this plus this gives us this plus this gives us this, and this one comes down. So we proceed again. We say this one comes down. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5, and this one comes down. I hope you understand. So proceed. We have this one also comes down. 1 plus 5, 6. 5 plus 10, 15. 10 plus 10 is 20. 10 plus 5, 15. 5 plus 1, 6, and this one comes down. So we go like that until we get to infinity. We proceed like that until we get to infinity. But let's have one more for better understanding. But in most cases, people stops at 7, 10, but it goes like that until you get to infinity. Then we have 1 plus 6. This one comes down. 1 plus 6 equals 7. 6 plus 15 is what? 6 plus 15 gives us 21. 15 plus 20 as 35. 20 plus 15, 35. 15 plus 6 gives us 21. 6 plus 1, 7, and this one comes down. So we're stopping here. So now, how does this affect binomial expansion? How does this Pascal triangle affect binomial expansion? It affects it through this way. We have a plus b, for instance, coefficient 1. In most cases, every case is mathematically, there's nothing like 1. There's nothing like raised to power 1. Once you see anything like this, you already know it's 1. It's when it's above 1, we start involving 2, 3, 4, 6, for example, and the likes. But when it's alone, it's known as a single coefficient. But now, for example, because I'm trying to explain, that's why I'm involving 1 here. So once you have something like this, you know it's just a plus b. I hope you understand. Because of this, we know it's just a plus b. So once we have a coefficient which is a plus b squared, a plus b squared, what are we going to say? Well, then we evolve this. We start from a. Then we start by saying a raised to power 2 plus 2ab plus b squared. So I want to explain something. You're starting from this. This decreases. The first coefficient decreases while this increases. Then you start involving every other number. You see, it starts with a squared. When we got here, it decreases to just a single a. Then b pops up, and we'll go to the last number. A was no longer there, and we have b squared. So let's try another coefficient. We have a plus b cube. Then we'll start by saying a cube plus, this is 3. We have 3. Like I said, it start decreasing. So we have 3a squared. Then what? When you have squared, what comes out? B pops up. I hope you understand. B plus 3 again. We have 3. A reduces down to just a single a. Then we have b squared. And lastly, we have what? B cube. And there's no way. I hope you understand. So let's get 3 or 4 more examples so that we understand. So we have a plus b raised to power 4 is equals to, we start from a, which is what? A raised to power 4 Now we're dealing with this coefficient here now. Plus, we're taking 4. We have 4 a raised to power 3. What comes up? B. Plus 6. A reduces to what? 2. B what increases to 2. Plus 4. A reduces to 1. B reduces to, A reduces to 1. B increases to 3. Then lastly, we have what? We have B raised to power 4. I hope you understand. So let's go to a plus b raised to power 5. A plus b raised to power 5. So we say a5 raised to power 5 plus 5. This is for this. So we're going for this. Plus 5. We have a what? I say a decreases. We have a raised to power 4. Then b what comes up. Then go to 10. Now plus 10. A reduces. So we have 3 b raised to power 2. Plus 10 again. A raised to power what? 2. B is raised to power 3. A reduces. B increases. Plus 5. A. Then we have b raised to power what? 4. Then lastly, we have b raised to power 5. So that is all about binomial expansion. And if you know this, you can easily use this to factorize. Using binomial expansion, you can use it to factorize when you're asked to factorize anything mathematically. You can easily use this to factorize to get your answer without any stress. Thank you very much.